Hello and welcome. In today's video, we're going to be exploring the laws of exponents by showing examples of why these laws work and why they are the way they are. So let's dive right in. Let's start with the idea of what an exponent is. Simply put, an exponent is the notation we use for repeated multiplication. So for example, if I'm doing 2 times 2 times 2 times 2 4 times, then we're going to write that as 2 to the fourth. Now, part of this definition is that the 2 there is called the base, and the 4 is called your power or your exponent. So in this way, if we had 7 to the second power, it would be 7 times 7. So again, 2 copies of 7, and 7 times 7 is 49. Whereas if we had 4 to the third, this would be 4 times 4 times 4, or 3 copies of 4. And 4 times 4 times 4 is 64. All right, so now that we have the definition, let's take a look at our most basic law of exponents and explain why this works. That is, what happens if you have x to the first? Well, the idea is if you had x to the third, it would be 3 copies of x. And if you had x squared, it would be 2 copies of x. So if you have x to the first, it should just be 1 copy of x. So in this way, x to the first is always just equal to x. So that's our first law of exponent. X to the first is equal to x. And again, that works for any x. So 2 to the first is equal to 2. 3 to the first is equal to 3. 5 to the first is equal to 5. For our next law of exponents, let's look at this a little bit different. Let's think about the number 1. And if I asked you how many copies of 2 are there in the number 1? Well, there aren't any 2's there, so we would say that there's 0 copies. So in this way, we could say 1 is equal to 2 to the 0. Similarly, you could say how many copies of 3 are there? Well, we would say there's 0 copies of 3, so 1 is also equal to 3 to the 0. And we can do this on and on. So 1 is equal to 4 to the 0, and this is true for almost every number, and we get the law of exponents that x to the 0 is equal to 1. And again, this works for almost every x. The only x it doesn't work for is 0. All right, our next law of exponents concerns the product of powers. So for example, let's say we had 2 squared times 2 to the third. What should we do for our law of exponents? Now, you might already know the answer, but if you didn't, one thing you could do is just write out what 2 squared is. Again, it's 2 copies of 2. And then write out what 2 to the third is. It's 3 copies of 2. And then we could just simply count up how many copies of 2 we have. Well, total we have 2 plus 3 copies, so we have 2 to the fifth. So in total, all we did was add our 2 exponents, 2 plus 3, and that got us our new exponent, 2 to the fifth. All right, so that will work in general. So if we had x to the m times x to the n, well, x to the m is m copies of x, and x to the n is n copies of x. So in total, how many copies of x do you have? Well, we would just add those numbers together, and we get x to the m plus n. So this gives us our next law of exponents. X to the m times x to the n is equal to x to the m plus n. Or in words, we would just say when we multiply 2 powers, we add the exponents together. So for example, if we had 3 squared times 3 to the fifth, this would be 3 to the 2 plus 5, or 3 to the seventh. All right, let's take a look now and see what happens when we divide powers. So let's say that we had 3 to the fifth divided by 3 squared. So 3 to the fifth is 5 copies of 3 on the top. And then 3 squared is 2 copies of 3 on the bottom. And we can see of those 5 on the top, 2 of them are going to cancel with the ones on the bottom. So we're left with 5 minus 2, or 3 copies of 3 overall. And of course, this doesn't just work with 3's and powers of 5 and powers of 2. This works in general. If we had x to the m divided by x to the n, when we divide 2 powers, we're going to get some of those powers canceling out, just like in the previous example, and we're going to end up subtracting. Now, it should be noted that we can actually subtract in both directions. If we wanted the x's on the bottom, we could have also subtracted down to the bottom and wrote this as x to the n minus m. So let's take a look at an example of that. So let's say we had 7 to the third divided by 7 to the 6th. Okay? So here, since the 6 is bigger on the bottom, a lot of times in algebra, you might want to simplify this down as 1 over 7 to the 6 minus 3. So in general, when those powers are crossing that division bar, we're going to do that through a subtraction. And it doesn't matter which way this goes. We'll end up with 1 over 7 to the third here. Now again, we could have done this the other way. 7 to the third divided by 7 to the 6th is 7 to the 3 minus 6, or 7 to the minus 3. And we'll see that these two answers are actually equivalent to each other, and we do actually want to know how to do it in both directions. But again, our law of exponents is that when we divide two powers, we're going to end up subtracting those exponents, and again, we can do that in either direction. Subtract them to the top or subtract them to the bottom as needed in the problem. All right, our next law of exponent is what happens when we raise a power to a power. So let's say that we had 2 to the second, and we raise that to the third power. All right, again, let's just write this out. 2 to the second is 2 times 2, and then we're raising that to the third. So this would be 2 times 2 times 2 times 2 times 2 times 2. So we have 2 copies of 2 times 2 copies of 2 times 2 copies of 2. And overall, this is the definition of multiplication. 2 plus 2 plus 2 is equal to 2 times 3, or 6. So we get 2 to the 6th. And again, this works in general. If we have x to the m, all raised to the n, this is going to be x to the m times n. Or in words, when you raise a power to a power, you're going to multiply those exponents. So an example here would be 7 to the third, all to the fourth power is going to be 7 to the 3 times 4, or 7 to the 12th power. So next, let's take a look at what happens when you have a product, let's say 2x raised to a power, so 2x to the third, for example. Well, again, our definition would say that this is 2x times 2x times 2x. And then because we can multiply in any order that we want, we could rearrange this as 2 times 2 times 2 times x times x times x. And we'd end up with 2 to the third times x to the third. So this, of course, will work in general. Let's say we have a general product, x times y, and we raise it to a power, n. Well, then that power can distribute through the product, and we get x to the n times y to the n. Now, similarly, if we had a fraction, x divided by y, and we wrote this out, we would have x times x times x on the top, and we'd have x to the n on the top, and y times y times y on the bottom, so y to the n on the bottom. So x over y to the n is the same thing as x to the n over y to the n. So simply put, powers can distribute through products and quotients or divisions. All right, for our next law of exponents, let's take a look at 1 over 7 to the third. And we're going to use some of our laws of exponents we have from before and generate this negative exponent. So remember that 1 is the same thing as 7 to the 0. So we'd have 7 to the 0 divided by 7 to the third. And now we can subtract those two exponents, so 7 to the 0 minus 3, or 7 to the minus 3 power. So here we can see that that negative 3 power corresponds to putting a positive 3 power on the bottom. And again, this isn't a fluke, this happens in general, that if we have x to the minus n, that's the same thing as 1 over x to the positive n. Okay, and again, that will work in general as long as x is not equal to 0. Now, I like to think about this law of exponents as when you move a number from top to the bottom or from the bottom to the top. So for example, let's say we had x to the minus 5 on the bottom and we want to move it to the top, then we're going to change the sign of that exponent. Okay, and this works regardless of the way that we move it. Let's say we had x squared on the top and for some reason we needed to move it to the bottom of a fraction, then we would just change the sign to x to the minus 2. Now, an even more general rule for negative exponents is if you have a fraction, let's say x over y, and we raise it to the negative n, we can take the reciprocal of that fraction, y over x, and raise it to the positive n. Okay, so for example, let's say that we had 2/3 and we raised it to the negative 2. This is the same thing as 3/2 raised to the positive 2, or 3/2 times 3/2, or 9/4. All right, so next let's take a look and see what happens with rational powers. So for example, what should x to the 1/2 be? All right, and here I'm going to use some of my laws of exponents to kind of figure this out. Well, x to the half times x to the half, according to our laws of exponents, should be x to the half plus a half, or x to the first. Okay, so now we need to think of what do we multiply by itself to get back to x, and that is the square root of x. So each one of these x to the halves should be a square root of x. All right, now this would work also with x to the third. If we did 3 copies of x to the third, that would also be x to the 1/3 plus 1/3 plus 1/3, or x to the first. And what can we multiply by itself 3 times to get back to x to the first? Well, that would be a cube root of x. So x to the 1/3 should just be a cube root of x. So in general, this gives us the rule that x to the 1 over n is the same thing as the nth root of x. So for example, if we had x to the 1/4, this would just be a 4th root of x. And this rule works in both directions. If we had a 7th root of x, this is the same thing as x to the 1 over 7. All right, let's look at the general rule. Let's say that we had x to the m over n. Well, we could use our laws of exponents and say this is x to the 1 over n, all raised to the m. Okay, and that 1 over n becomes the nth root of x. So we could say that it's the nth root of x raised to the nth power. And then the way that roots work, we could also write this as the nth root of x to the m. Okay, so we actually have this law of exponent here. Now, like all rules in algebra, these rules work in both directions. So let's say we had the cube root of x to the 7th. We could rewrite this as a power. So the index of the root, or the type of root you have, that's going to become the denominator. So that's going to become a 3rd power. And the power of x is going to become the numerator. So the cube root of x to the 7th becomes x to the 7/3. Okay? If you had a square root of x to the 5th, now we don't write an index there, but it's implied to be 2. So that 2 is going to become the denominator. And again, this x to the 5th, that 5 is going to become the numerator. So let's take a look at some practice problems for algebra where you typically want to simplify your expressions so you only have positive exponents. And we're going to use our laws of exponents here. Again, the first one here is that the product, this 4, can distribute through this product. So we'll get 2 to the 4th, and then we'll get x to the 3rd to the 4th. And again, when you raise a power to a power, you're going to multiply those two exponents. So you're going to get x to the 3 times 4. On the bottom, we have x to the -2. I'm just going to leave that alone for now. Now, 2 to the 4th, we can multiply that out. We'll get 16. And then x to the 3 times 4 is 12, divided by x to the -2. And these rules work with positive powers or negative powers. When I divide two powers, I just subtract those two exponents. So x to the 12 minus a -2, or overall 16x to the 14th power. All right, let's look at another example. Here we have x squared divided by y to the 3rd, all raised to the -2nd power. Now there's a number of ways to approach this, but I'm going to start with this negative power, that to raise something to a negative power, I can reciprocate it or flip it upside down and then switch it to a positive power. So instead of x squared over y to the 3rd, we could rewrite that as y to the 3rd over x squared, take the reciprocal, and raise it to that positive power. And now this 2 can distribute to both of these. And again, when we raise a power to a power, we're going to multiply those powers. So we're going to get y to the 3rd squared, is y to the 6th on the top, again multiplying those powers, and x squared squared is going to be x to the 2 times 2, or x to the 4 on the bottom. All right, let's take a look at another one, and I'm going to approach this a little bit different. This time, this -2, rather than taking a reciprocal, I can go ahead and just distribute it. Even though it's a negative power, I can do that first if I wanted to. I could have done this on the other problem if I wanted to as well. And I do 7 to the -2, y to the -2, and then x to the 5th, cube root of that is going to turn into x to the 5/3. Okay, again, using my rational powers laws, and then I'm going to raise that to the -2. Okay, on the bottom we have x, and then the square root of y is going to be y to the half. Okay, let's simplify this in part. X to the 5/3 raised to the -2. I'm going to multiply those two powers, and this is going to become x to the -10/3 when I multiply 5/3 times -2. Now let's simplify this so that we get positive powers. So remember that when you move a power from the top to the bottom, it's going to switch the sign of the exponent. So we can move that 7 to the -2 down to the bottom, and it becomes 7 squared. Okay, we can also do our laws of exponents for the subtraction. We can do x to the 1st minus a -10/3. And again, you could subtract to the top or the bottom. Here I want to subtract to the bottom, so I get positive exponents. Similarly, we would have y to the 1/2 minus a -2. Okay, now when we do all of this, it's not going to leave nothing on the top. You don't want to put a 0 up there. We're just going to leave 1 up top. Okay, and finally, all we need to do is simplify all these different parts. So 7 squared is 49. X to the 1 minus a -10/3 is going to be x to the 1 plus 10/3, or 13/3. And then y to the 1/2 minus a -2 is 1/2 plus 2. And when we do that addition, we'll get y to the 5/2. All right, I also wanted to take a look at a few problems using laws of exponents as you need them in calculus. Now, you will have to simplify things similar to how we just did, but also in calculus, you're going to need things called the power rules for derivatives and integrals. And when you do that, you want to use your laws of exponents. You don't always want positive powers. You want to write it as a sum or difference of constant multiples of powers of x. So let's look at this one. We have 5/7 cube root of x squared. So our first thing is to remember our rational law of exponents that says a cube root is going to become a 3rd power, and then x squared, that 2 becomes the numerator. Okay. Now again, if you're in algebra and you're trying to look your answer up in the back of the book, this is a perfectly reasonable answer. But in calculus, I want to write this as the constant multiple, 5/7 as a constant multiplier, and then I actually want the negative power. Then I want to move this to the top and change it to x to the -2/3. So I need to move it into this form so that I can use something called the power rule, either for derivatives or integrals. All right, so let's take a look at another one. And just a reminder that when we do x plus 2 squared, we can't just square each one of these terms on the top. Instead, we have to think about this as foiling x plus 2 times x plus 2. And when we FOIL that out, we'll get x squared plus 2x plus another 2x, so plus 4x, and then plus 4, and then all over 3x. Okay. Now we need to remember the way that fractions work. If we have a single term on the bottom called a monomial, it can divide into each one of the terms on the top. Okay, so we could rewrite this as x squared over 3x plus 4x over 3x plus 4 over 3x. And now, using our laws of exponents, the first one, the over 3 just becomes a 1/3. And then x squared divided by x is x to the 2 minus 1, or x to the 1st. The second one, you really don't need laws of exponents. You can just see the x's cancel. So you'll get 4/3. And for our last one, we'll get 4/3 again. And again, I want to move this x to the top. And the way that that x gets moved to the top is switching the sign of the exponents. So it's going to become 4/3 x to the -1. And as always, please take a moment to like this video and subscribe to my channel.